you please introduce yourself and then begin with what you have to share?
Okay. Yeah. So, hello everyone. My name is Tejas. I'm from Eggheads, and I would like to call myself a computer geek who's broken in his hands not once but twice. So today I'd like to present to you about the project I've been working on for the past 4 months, which is an electric generator. And the reason why I wanted to work this is actually a bit special for me, and I'll explain it to you at the end. So should I start my presentation? Okay. Give me a second. Can you see my screen? Okay. Yeah. Okay. So to start off, what is an electric generator? Wait. Oh, sorry, but can you see my screen? Okay. Uh, Once again, just showing me a message saying that it's not coming. Can you just give me 1 second? I'm very sorry.
Yeah,
it's no
please
problem.
take your time. It's okay, Tejas.
We did see your screen. We did see it.
Oh,
Yeah, we
but
did see
it's
you.
giving me some message over there.
Well, ignore the messages. We saw it.
Yeah, listen to us. We saw it.
Yeah, listen to our message, not the
Yes.
computer's message.
Sorry. Yeah. So I'll just do this. I'm not share my screen. Okay.
We see it.
Yeah, you can see, right? Yeah. So what is an electric generator? In simple sense, it creates electricity. It is what is right now powering your house and letting all of us talk to each other. And another way to call this is a dynamo. And what this machine does is it converts mechanical and energy into electricity. And you usually transmit this electricity to the power line that you have. And for you use it for domestic, commercial, and industrial customers. So now, how does this project actually work? So there's a few parts of the electric generator. The main idea is it works on the principle of electromagnetic induction, which I'll break down how well I could understand it. So what happens is whenever you move a magnet, there's actually a subtle change that you can't see, but it is happening. And there is a change in what is called its magnetic flux, which means there's a change in its magnetic field. So now when this change is actually happening, if you put a conductor next to it, for example, a copper wire, this change is actually somehow able to, it's actually able to interfere with the electrons in the conductor, and it's able to induce the current into it. Give me a second. Yeah. So basically, it induces current into it, which is just a fancy of saying it generates the current into the coil. So this is the phenomenon of how it works. And in all honesty, we still don't know a lot about it. So now, what do you need to actually make this project? So I'm going to talk about what materials I used to make this project, but then the steps of actually making it can be easily done with whatever material you have. So first and foremost that you will need is a strong magnet. And I would really recommend a strong magnet, as you'll see the mistake I have personally done. But yeah, the next thing that you need is a copper coil, a lot of it, because that is actually what's going to get the current from the magnet and going to give you the electricity. After that, you also need cardboard as your frame, a hot glue gun just to stick it up, a few sticks, you'll see why, and a multimeter to check how much voltage is being produced by a electric generator. So how do you actually build this? So the first step of building this is you need to actually create a frame, because the main part about this is getting that magnet moving or rotating. So what I did was it's funny, I had a plan written in Sketchpad, but so what I did was I took a cardboard, cut it into your doctor's plus sign, and fold it in such a way where it almost resembles a square. And I accidentally made a mistake where two of my cuts were a bit too short. So that's why it's a bit inclined, but I still feel it actually helped a lot with the design also. Because it's a lot more sturdy if you think about it. So yeah, happy accidents, one would say. After that, you need to have a stick, or in my case, a pencil, which you will use to actually rotate. So you need to actually rotate the magnets. So I use a pencil, and my magnets were in such a way where I had a hole in the center of them. So I stuck two cardboard circles on it and then put a hole right through it. So I got it to actually spin on inside the cardboard. Then the last and final step is you need to actually rotate the copper coil around it. So now during this whole process, there were two things I was actually very keen on, and that was one, I needed to get my magnet moving fast. You see, the electricity generated by a generator actually depends on how fast you turn it. In a sense, even if you have the strongest generator, if you turn it very slowly, you won't be producing much of an output compared if you turn it really fast. So I made sure I was actually able to turn it really easily and as quickly as possible. Another requirement, which I would say is actually personal to this project because I had a bit of a weaker magnet, was to get my copper coil as close to the magnet as possible. So for the generator to actually create electricity, you need to have the copper coil inside a magnetic field. Otherwise, it won't work, because when that change happens, the copper coil has to be next to it. And my magnet was in such a way where unless I kept it this close, it wouldn't actually attack. So I was very keen on making it very nearby, close to the actual magnet. So if you see my model, it's actually kind of touching it, but not exactly. So now what my aim was in the project? The aim was to create a generator that can produce about 0.5 volts and that can power an LED out an LED. And the reason I said 0.5 volts specifically was that that's like the smallest LED you can get, which that's the smallest LED with the smallest charge that you can get. So, and this is now my prototype I'm going to show. Forget my voice because it sounds terrible, sorry. But yeah. So as you can see, I'm actually able to spin the magnet really fast. And on the multimeter over there, it's showing the readings. So the max output I got was 0.02 volts, which may sound very little, but it's actually very hard to get to that much. So yeah, as you can see. And you also notice that this kept changing. That's because my human hands are human hands, and I can't do it like a robot and constantly churn it. So I kept slowing down and speeding up, and it's sure on the multimeter, sadly, but okay. Yeah. So now
Your human hand is broken twice.
you know, this actually happened before that, so I'm kind of envious of the video person. But okay, so now as you saw, I told you my max output was 0.02 volts, and there were two major problems that actually caused it. The first one, and the actual problem, is that I use a very weak magnet. I use a magnet that you'd normally find in your speakers. And I tried searching around, but I couldn't find a stronger magnet. And the one I did find was a bit my friend, and he couldn't really give it to me because he was finishing his own. So that's the first problem. The second problem, that's actually a minor problem, is that the number of turns I did was few. And the number of turns I did for this one especially was actually 300, which may sound a lot, but compared to here, it's actually a lot less. So, but still, even if I did do like 600, 1200 turns, it would increase, but then not enough to actually for me to power up my LED. All I'd be doing is breaking my hand even worse. So yeah. So now how I can fix this is pretty obvious. I could buy better magnets, and I will buy it once I get the chance to actually. But yeah. So now what is my future plans? So as with any project I do, whether it be personal or school project, I have some goal in mind that I want to achieve. And this one is no different. So my main motive for this is, well, let me bring in a backstory. How many of you guys have gone on long road trips? You know, those cross-state, cross-country road trips. Okay, I can see one, but still. Okay, two, yes. Okay, I see you've all gone there. And how many of you actually enjoyed it? Curious to know. Okay, I'm very sorry to say, but I hated the road trips. I just don't like the car at all. Just something about the smell and stuff. But one thing that really bothered me during these things were when my phone or laptop got out of charge, which happens quite often than not. So I had an idea where, if you think I wanted to make a generator in my car itself, that was small enough to fit in it, one thing, but strong enough to actually power up my phone / laptop. So I'll explain how more detail on how I want to do it. And the first idea is, so first thing, of course, I need a rotating post, and that is of course going to be the car wheel, because that's going the fastest in the car and that is going the most notably in the car. So that's the first step, and I think once I get that down, I just need a strong enough magnet and the rest should be a piece of cake, hopefully. But yeah, I'm going to make this one day to solve my problem of staying in that terrible road trips. But until then, I'm pretty happy I did this project. Otherwise,
how old are you?
I am actually 13, going to be 14. So I call myself 14.
So 10, 12 years from now, and then you tell me, do you like long road trips or no? Jake, even if I'm not alive, I want you to ask him after 10 years, I mean, in the next gift, I want you to ask him the question, even if I'm not there. Does he like road trips or no?
What do you want me to ask?
Yeah.
Wait,
Tejas, by the way,
Gia, do you have any questions or comments, Gia? No, we can't hear you.
Yeah. By the way, Tejas, a wonderful presentation and a wonderful way of presenting it. I'm really happy because it just told us that how you were keen and engaged in the whole project. You just didn't do it as a matter of doing an experiment and so on. So you were having fun, you were learning, you were presenting your hypothesis, you were trying to do it this way or that way. That's the best thing. So, and I really love the idea of yours that because yes, there's a problem on this long road trips. Not with the adults, but definitely with your teams. The phone battery, or maybe the laptop battery definitely just gives you start giving you alerts. So it can be a wonderful idea that Tejas says what we say generator is going to help us charge our mobiles and make us love the long road trips even better. By the way, Tejas, I just noticed that you people are from homeschool. Because this is what I wanted to raise as a matter of fact. So are you homeschooling yourself or someone's homeschooling, or do you go to some school or institution?
Actually, our school is in such a way where it is a homeschool, but then our school itself provides the classes. So we have 3 hours a day. And during those, we have math, science, English, and ICT. ICT is just a fancy way of saying computers. I just like computers better than ICT. Yeah.
All right. Perfect. Sounds nice even. So it's sort of a homeschool. And have you ever been to a regular school as well in your life?
I've been for a regular school most of my life and been only homeschooled for like 1 year.
All right. So what's the difference that you found? Because I really wanted to know, because this homeschooling thing is getting into like across globe. So what's the exact difference between when you were in a regular school and now when you're in a homeschool?
The main difference is you need to have a lot of self-control. Sorry to say.
No, it's not sorry to say. In fact, it is something very interesting and important to tell. So come on.
I still have a problem with this, but then it is so hard not to spend 90% of the day not on the screen, just watching YouTube all day. And thankfully, I have some kind of hobby that keeps me not on the screen. But yeah, it is a huge problem. So you need to really do that. And the second thing is if you really miss friends or if you're more of an outdoorsy guy, you won't really like it. Mainly because you meeting your friends on the screen. Sorry to say. And
Yeah.
you just, this class is fun, don't get me wrong, but then there's not much interaction with this students otherwise. That's my perspective at least.
So this homeschool is actually completely online kind of a school.
Yeah.
Yeah. All right. All right. So that's one major thing, by the way, when we talk about homeschooling. So everyone across globe is facing the same issue because we think that homeschooling is all about online school. So there's a difference between homeschool and an online school, definitely.
You miss our friends a lot in the school, but otherwise,
it's all about interaction. Yeah. So were some of your friends engaged while you were doing this experiment, or you were doing this project, or you were all doing it all alone, or were you just referring to someone, or you were doing it all through the online videos and YouTube?
Honestly, the only person that we all of us referred really was our own teacher. So our class teacher was so not class teacher, project teacher was so and he actually got this project for us, and then I came up with this idea that I wanted to do, that pushed me to do it actually.
Perfect. So do you people get to interact, the classmates get to interact outside the online environment, or no, just online?
Other than our school teachers asking us to like, okay, this self-study period, please do this, we don't really do much. So yeah.
Tejas, can you stop sharing your screen? So
Yeah,
it's taking up most of the room.
Yeah.
Now we can see everybody better. Gia, if you have any comments or questions, please just jump right in. Can we hear you now?
So I saw that you did some research. Can you hear me?
Yes, we do.
Yeah.
So I saw that you did some research.
No, now your voice faded away.
It did just.
I saw that you did some research.
I think maybe come back a bit because then we are able to hear you better. I don't know.
Okay, well, we're working on that. Okay. Tejas, is that how you pronounce your name? Tejas?
Yeah, Tejas.
Tejas. Gee, just keep working on that. Get that to work because we want to hear you. So I just have 3 quick things to tell you. First of all of these generators and motors and stuff were invented by Michael Faraday and around 1820, 1830. And if you go next time, or if you ever get to London, he has his laboratory is there, and you can go visit his laboratory and see the things that he made. And his devices look very much like yours. Okay, so he only beat you by 200 years. It's only by 200 years. He's only 200 years ahead of you, but it looks exactly like the kinds of things you made. So you can see what he did. It's very interesting. Michael Faraday. Yeah, Michael Faraday, the Royal Society in London, and you go to see that. It's wonderful. The other thing is you mentioned that electric fields and magnetic fields, and we don't really understand that, okay? And when I was in college, we had a professor who came and talked to us about this. And afterwards, I said to him, but why does a changing electric field create a magnetic field? And why does a changing magnetic field create an electric field? And he said, oh, and he filled the board with equations. Literally, for 45 minutes, he wrote equations. And when
I really need to be in that class because I've been searching on the net with no avail.
Well, wait. when he was done, I realized he didn't tell me why. He told me what was happening. We understand what happens, but we don't know why it happens. So there is a Nobel Prize for you when you figure out why it happens. They're very good. They have equations and equations explaining what happens, but they don't know why it happens. Okay? So you can have your laboratory just as famous as Michael Faraday's laboratory. He beat you by 200 years now, but there still is a big opportunity for you. Okay? Now, one more thing. A changing electric field creates a magnetic field. A changing magnetic field creates an electric field. Do you know what light is? You know, light that we...
Light.
Yeah, light.
I know it's electromagnetic radiation.
Yes, yes. Light, what we call light, is an electric field which is changing back and forth, and a changing electric field creates a magnetic field which is going this way. Okay? And so light is those two fields, the electric field creating a magnetic field and the changing a magnetic field creating an electric field, back and forth, back and forth. So what you have done is you have opened the door to a fundamental concept of the universe, okay? That it's not only generators and motors working each other, but light itself are these two fields. So when you answer the question of why does a changing electric field create a magnetic field and a changing magnetic field create an electric field, you're not only solving the issue of motors and generators, but of light itself. It's one of the fundamental concepts of the universe, electromagnetic radiation. So there's a lot to do,
And this is what happens when two engineers start talking.
No, I'm just saying.
This is what happens. They forget everyone else. It's
No. But I wanted him to know that what he has done is he has opened a door a little bit, and there is a tremendous amount of knowledge that is unknown to anybody. And so this is a very exciting thing for you to have begun.
Indeed it is.
And Gia now has
learning. Yeah.
Yeah. Gia, you now have new ears.
Hello.
Oh!
We can hear you.
Do you have anything to say? Yes.
Can you hear us?
Yes, we hear you.
Yes.
Come on, now ask questions or comments to Tejas.
So I really like the research that you did. And
Thank you.
yeah.
All right, so
Well, there is no limit to what you can be doing. Tejas, one of the things you want to try experimenting with is different orientations of the wire. I saw you wrap the wire one way. Try doing things different ways, okay? One of the things that I might recommend is you do not go on YouTube and look at what other people have done, because then you're just copying them, okay?
Yeah. Honestly, I first thing we did, my whole class did, in fact, was go YouTube and then search. We found a lot of videos, but in Indian, my sir was like, don't do it like this. And then I came to my conclusion of doing it in such a way where I told you the whole plus sign symbol and putting the, and I especially had to change a lot because my magnets were circular and donut shaped. So,
okay.
yeah.
So, here's the point. If you go on YouTube, all you're going to do is copy what other people have done, okay? You aren't learning anything. You aren't making any new discoveries. What you want to do is do stuff on your own, and this is a wonderful activity for you or anyone else to do stuff, and I'll tell you why. Because it's safe. Okay. If you're doing chemistry, there are some things you can mix with chemicals that are dangerous, that are poisonous, that could cause real harm. There's nothing you're going to do that's going to be damaging. Okay.
Yeah.
The worst thing that will happen is you will touch the hot glue gun and burn yourself. But I mean, you've already broken your hand, so that won't be a problem. But it's perfectly safe. It discover things. Okay. And so let me tell you, I'm sorry, I'm just going to tell you another story, because things are discovered, great inventions are made, great concepts are when something unexpected happens. Michael Faraday, the person who created the generator and the motor, he was actually a chemist, and he was actually doing chemistry work. And what happened was there was a gentleman, a professor in Sweden named Ørsted, and he was doing demonstrations on electricity and magnetism. And it was the concept that electricity and magnetism had nothing in common. They were completely different. There were magnetic fields, there were electric fields, and they were completely different. And Ørsted was a professor in Sweden, and at the university there, he would do a demonstration to his students.
And then,
do you know the demonstration?
Yeah, he had a battery in an electric circuit, and then right beside that, coincidentally, he had a compass. And we started with electric magnets, and then we moved on to generators, actually.
Okay.
So
but you missed the important part of the story.
Yeah.
He did a demonstration where he had the magnet and the compass and an electric wire, and he would run electricity through the wire, and the compass needle would not move. And that was the demonstration, because you have to understand, magnets attract, right? Magnets attract, and electric fields attract. And so they had the wire going this way, and he put the compass this way. And the theory was that if it was going to attract, that the compass needle would move. Whoops, I'm having trouble. Okay, this is the wire, this is the compass needle. It goes this way. That's what they expected to happen. And so for 100 years, people were doing this demonstration, and they expected the compass needle to move, okay? And for 100 years, it never moved. And one day, Ørsted, being a famous professor, he didn't set up his own experiment. He had a graduate student set up the experiment, and the graduate student set it up wrong. And the graduate student set it up this way. And then when they turned on the electricity, the needle went like that. And all of a sudden, they realized, oh, wait a minute, there is an effect. There is an effect. Nobody knew what was happening, but the effect was the opposite of what they were expecting. And that was the discovery, because the graduate student made a mistake. And when Faraday heard about this, he switched from chemistry to becoming an electrical engineer. Now, Faraday is famous. Ørsted is famous. What was the name of the graduate student who made the mistake and allowed the discovery? Nobody knows. He is the person who actually made the discovery possible, and he's not famous.
Very bad.
So, Tejas, the reason I'm telling you this story is because if you go on YouTube and you build what other people have done, all you're going to do is build things that we already know that work. What you want to try is things that you don't think will work. You don't think will work. They shouldn't work, because every once in a while they will work. And that is the discovery. That is the invention, not just copying what somebody else has done.
Yeah.
Okay.
Wow, Jake, thank you very much. Now I know what mistakes bring you up with.
It was a mistake. It was,
Yeah.
you know, they were expecting this to happen, and instead it was the opposite.
I heard of it when I was in
Mistakes
my
change the
pre-engineering.
world in one day.
No, by
There's-
one mistake.
Happy mistakes.
Yeah, exactly. As
So,
you say,
so
happy
yeah,
accidents.
make as many mistakes as you can. And also the other thing is write down what you've done. Okay.
Yeah.
Because what'll happen is you'll do something and then something strange will happen and you go, what did I do?
Why did
I want,
happen?
I want to do that again. And you don't remember what you did. So you need to keep a manual, a document, write down, draw pictures of every experiment, write down what you did, write down the results. Okay. And that's how then when something happens, you go, oh, wait a minute, let me try something. Let me go back and duplicate it and try it again. Okay, that's what you've got to do.